Hello and welcome to the Smooth Scaling podcast, where we are speaking with industry experts to uncover how to design, build, and run scalable and resilient systems. I'm your host, José Quaresma, and today I'm joined by Barnaby Clark, the CEO of Lineup, a ticketing commerce platform. We talked about the challenges of ticketing and how Lineup addresses them. Specifically, we talked about designing and running scalable ticketing systems to meet peak demand. We talked about being able to predict traffic and how, the impact that it has on your ability to scale, and how bots impact the industry. Enjoy. Welcome, Barnaby, to the Smooth Scaling podcast.
Great to be here.
It's great to have you. And I would like to start a little bit with you telling us a little bit about yourself and what led you to founding Lineup.
Sure. So my background, I started in M&A and corporate finance, working with a lot of tech companies, but really had a deep passion for live entertainment and live experiences. And with a couple of people I'd known for a long time, we came up with an idea of building a company in the live entertainment space, really with the mission being to try and get people to more live events. That evolved, as many startups do over time, into the ticketing space, and then we started working with a number of venues across the UK. And then COVID happened. During COVID, we took the decision to completely rebuild Lineup from scratch and take that opportunity of kind of the live entertainment industry being shut down effectively to build a really modern system using everything that we'd learned from our years of experience working in the space. And coming off the back of COVID, started working with some really exceptional venues and focused on live commercial entertainment and ticketing West End venues. And venues in Broadway, off Broadway, and across the UK.
And talking about the ticketing, right? And I mean, ticket on sales, right, are very interesting in different dimensions, but also kind of, and especially in the scope of this podcast from a technical standpoint. You often have limited inventory and kind of a big traffic peak usually, and you have bots and all that. Can you tell us a little bit about the considerations when operating in the ticketing space in this area, and potentially kind of what does a typical user journey look like? Would be good to know as well.
Yeah, I think ticketing has some really unique challenges when you're thinking about scaling, and I mean it's a subsector of e-commerce, obviously, but unlike most of e-commerce, you've got some sort of very different challenges in the ticketing space, and they're not consistent. They depend on the type of on-sale you're doing. So I think one of the challenges you have is you can have an on-sale where you've got very limited inventory and a very high demand. That's the one that people often think about. So big name act or big name concert where you've got very large numbers of people coming to a site all of a sudden, and often there's a sense of a gated entrance. So people know when they're coming to the site, they're hitting that site, trying to get in, and suddenly you open the floodgates. So that's one challenge. But then you have that can happen in an unpredicted way. So you can have a situation where you have a famous actor or a famous star sends out a tweet or sends out a message to their fan base and drives unexpected high loads of traffic into a flow. And then you have other situations where you might have plenty of inventory across a long run, but you have a lot of people coming through that. So you're looking at how you can maintain a very high transaction throughput and a good user experience. So I think that there's several different challenges. And then I think the last thing to think about in the ticketing world, again, because you can have seated events or geo events, but if you think about a seated event, it's not so much like the e-commerce model where you have a stock of 1,000, and yes, you need to track that stock and make sure you don't sell out. In ticketing, every seat is a unique piece of inventory, so you have to think about making sure that people can get seats next to each other, that you're not just letting hundreds of thousands of people try and book 100 seats where no one's going to get seats in a group or next to each other. So there's some quite unique challenges there in terms of how you manage the systems and the scale for that.
And so in lineup in your platform, right? Can you share a little bit on what does a typical user journey look like? I think that will help us then when talking about addressing those challenges.
Yeah, so most of the journeys, and it kind of depends on the phase of the event, but most of the journeys, I would say, so we have an average time to purchase of about 4 minutes. So people are coming in, they're usually going to see a calendar. We're usually talking about a single show journey, so they know what show they're coming in to book. They're going to see a calendar of dates. They may have an idea of what date they're booking for, or they may not. They may be looking more on the break pricing and availability. Once they've picked a date, they're then going to either see a GA flow where they can, a general admission, where they can just pick different price points, or they're going to pick a specific seat or set of seats. Once they add their seats to their basket, they're going to go through, see upsells, products, merchandise, other things that they might want to buy, and then they're going to go to payment. So, each of those steps will take them a different amount of time, but the key ones for us really are when they're thinking about picking their seats, at what point do we hold those seats, making sure we reserve those seats for them, and then through to the transaction page and making sure that we can have a good throughput of transactions. Those are the pressure points for us in terms of the infrastructure. Is where we're making writes to the database and where we're creating new transaction items.
So the user journey then kind of up to that selection of seats, right? Then why is it that is not as sensitive for you as then the seat choice?
Well, I think for us, we kind of split the journey into what we consider to be read and cacheable data versus when we're starting to make writes. So if you think about the early parts of the journey, a lot of that data, what date the show's on, that's not changing much. The price, yes, the available prices are changing, but they're not changing as dramatically as the seat availability. So a lot of that early part of the journey, you can rely on a certain level of caching, and you are or running off of a read replica of the database. So you're not worried so much about lock contention and things like that. It's the point that you want to start holding those seats, and even that is a decision that different systems make around when they hold those seats. Do you hold those seats the minute someone clicks on them, which is great. That means they've got the seat, no one else is going to take them. But the flip side to that is you're going to have a lot more writes onto the database. Or do you wait until they kind of get the seats they want, put them through to the next page, and then make a call on, at that point, I'm going to try and hold the seats and risk saying to them, the seats that you clicked on are no longer available because, there's 50 other people on the page at the same time who picked up the same seats. So it's, for us, the journey's split between kind of what you can do in, I guess, read-only write mode, where you're primarily pulling off a cache. That's fine at high volume, versus restricting the writes into the data and where you might have contention because you're making sure that, if you've got an inventory pool, you've got to be careful about how you're monitoring that.
That's kind of looking at it from that split and that two different perspectives, and what kind of the impacts that they have in the I guess the requirements towards the infrastructure. That's I think super interesting and helpful as well to then, I guess, when you design your infrastructure, right?
Exactly. And I think obviously, as much as you can rely on that, the read stuff and then optimize to that. So for us, in terms of how we think about the APIs that we're designing and building, we do think about them very differently. And we can direct read APIs to different database clusters. We can cache them. We can do other things with them. So splitting out each API call that we might make through the journey into, right, how is this going to mutate anything? Is this purely just giving people information? Down to how we think about how we rate limit them and how we control traffic on them. It's important to us to think about this differently.
And once you get, so I guess then one of the challenges is on the second part of the journey where we have the mutating actions, if you will. Then I guess that's where you start addressing the scalability challenges, right? So kind of, I think you have been thinking a lot and doing a lot on kind of being able to scale quickly. Can you tell us a little bit more about that?
Yeah, sure. So I think one of the kind of unique things, not completely unique, but one of the unusual things in the ticketing industry is this kind of sudden burst in traffic. So if you have a show going on sale at a specific point in time, on a specific day, you can have a sort of 100x increase in traffic to an API that is entirely legitimate. I mean, it might look like it's a denial of service attack, but it's not. It's legitimate. Lots of people trying to book tickets. So you have to think about how you can. Obviously, you can put queues and other things in place to try and protect the service. But ultimately, you have to think about how you can scale into that traffic, because you don't want to keep people waiting around. So a lot of what we've been thinking about is how you can optimize that scaling. And obviously with modern infrastructure, and we're running on Kubernetes, and that's fine. We can turn on new pods, but things like how long does the container take to start up? What does the cache look like for the container? Am I having to download that container fresh for every new pod I want to turn on, or have I got a shared cache? What's the startup time? Can I offload things that might delay the startup time into other microservices? So thinking about how quickly you can scale up, and then thinking about how you need to scale up all the parts of the infrastructure. So it's not just scaling up the API pods. It might be, you need to scale up the database, you need to scale up replicas, you need to scale up cache, and how long does each of that bit take? And then that leads you into sort of how can you do that predictively, or how can you think about doing that in advance? So yeah, a lot of the energy and effort that we've been working on over the last couple of years has been thinking about how we can optimize that scaling and how quickly we can do it, and how we can get it to a point where it's as automatic as possible.
And I mean, in that predictive space, kind of what are some of the things that you have done, or that you're looking into? Is there something that you can and would like to share?
So I think there's a couple of things we've done, and different things. So I think that there's some really good auto cluster scalers out there now that are doing things in smart ways, and we've used those. Those have been quite beneficial. But I think the really interesting one for us is thinking about how you can kind of take signals from earlier in the booking journey to help you to scale for later on. So if you think about what we were talking about earlier, you've got a lot of people coming into a queue, or coming into a waiting room, or sitting around waiting for an event to go on sale. Now they might be putting read-only data, or there's some indication that those people are there. You can use that information to start to scale into it, even if you don't know that event's going to happen. And then I think, again, if you think back to that journey we talked about, the early part of that user journey is read-only, it's discovery, it's finding a date, it's finding the pricing. Now, at some point, you're going to have to scale the right side of the infrastructure. But you can use the kind of information about the early read journey to think about, right, well, I need to start scaling up the right part of the database. I need to start scaling up my asynchronous task queues and things like that, because I've got an influx of traffic on the read side. That means that I'm going to start seeing a much bigger throughput on the transactions. So I think it's picking up signals from user actions earlier on that you can then leverage to start to kind of scale in advance and be ready for when that traffic moves through that journey. I mean, if you think, as I said, we've got a 4-minute average journey from start to finish. That gives you more than enough time to be ready for that traffic once it's got through. It's once people have decided what date they want to go, once they've seen the plan. And by the time they start adding seats to their basket, our philosophy is that we've got enough early signals on that we should be able to scale into that without us having to intervene.
Yeah. And in those early signals, are you usually thinking about mostly kind of overall load, or are you trying to work on making it kind of as specific as possible, or is that maybe not as important from a load perspective? Whether it's I guess you know which kind of shows people are waiting for, but which areas of the stadium, let's say, they are more interested in? Is that something that
I think that's an interesting one. I'd say that's a slightly different challenge within the scaling, which is how you scale the data sets that you're dealing with. And again, that's an interesting challenge that this industry gives that some other industries might not. So, I mean, that good example of that would be an arena, where, so again, I think a lot, when you start building a system, often it can be tempting to build it and say, right, I'm going to design, a way of showing seating plans, and you build it and you pick a seating plan, you build it for 1,000 seats, and then someone comes along and builds a venue with 100,000 seats. And so, it's about thinking about the data sets that you're handling and how big they can become, and how you can think about what the maximum challenge would be, or how you would break that up. So, and an arena would be an example of that, where if you look at an arena on our system, we're not going to load every seat on the page view. When you look at that, we're going to chunk that up into blocks. We're going to aggregate that data and then load an aggregate view and kind of let you dive into it at different sections. We're going to, so it's about how you slice up that data, especially on an API where you can paginate, but it's not always great to paginate on a client experience like that. You don't want to paginate through a seat list. I mean, the client wants to see, when I'm on a browser, I want to see all the seats in the area. I don't want to have to like press load more or something. So it's about tying in your user experience and your UI with how you're going to load that data. The other thing for us that we have to think about is a large percentage of the tickets that we sell are sold through third parties over an API. So there's only so much we can do on our, we're transacting a lot through an API with third-party sellers. So it's also thinking about how you can structure an API in a way that people can't break it, or people can't say, I want to load 100,000 things, and then that's going to cause a problem. So I see that as a slightly different scaling problem, but it's a scaling problem from a data architecture problem rather than an infrastructure problem.
And you mentioned kind of the third parties that you're integrating with from on the purchase side.
So other services reaching out to us to use our API to sell tickets. So from our perspective, a lot of West End tickets especially are sold through third-party ticketing agents. So they're sold through other platforms whether that's mobile apps, whether that's other things that are using our API. So, I mean, I think just within the ticketing industry, that there's usually one primary system that sits at the venue, and that in places where we operate, that tends to be us. So we would be the one that's kind of the source of truth at the venue in terms of who sat where. But that means if somebody's booking through a third-party system, that booking has to come into us. So a lot of the traffic and a lot of the transactions that we do are API-based. They're not through, and the majority is through our booking flows that are white-labeled, but we do have a significant portion through the API. And one of the decisions we took early on was to, rather than to have kind of a segregated API or a separate API, was to maintain a single API, partly because I think you get a lot of engineering benefits from just focused on people transacting over the same API. It can scale in sync, which makes sense. But that does mean we have to think about not just how we're using it, but how other people might use it. And making sure, as I say, that there are protections in place that mean that if somebody decides to drive a lot of traffic to that API, and that's things like rate limiting at different levels, and so we operate rate limiting both at the overall level, but then we have protections around rate limiting on the right side, so that, again, making sure that whoever's interacting with that API, whether it's ourselves or third parties, that there's systems and protections in place to make sure it scales. And I also think there's this thing, I don't think scaling is a binary thing. I don't think you either scale or not scale. I think there's an element of what happens if what happens while a system is scaling up to the capacity. So obviously you can put queues and things, but there's no guarantee that someone will have done that. So it's what protections do you have for the system while it's scaling into traffic.
Do you have any external dependencies that you need to take into consideration as well?
We do, yeah. Yeah, mainly payment providers. I think one of the interesting things there, I mean, we work with the three big ones, Square, Stripe, and Adyen, we've never had any issues with them in terms of scale. But what is interesting with the way that payment has gone, and I think this is the scaling as well, is a lot of that is now asynchronous. So especially with 3D Secure and things like that, your payment completion, and that moves your transaction flow to be asynchronous as well. So again, that's a slightly separate scaling consideration, which is if you're now relying on webhooks coming in to complete payments, complete transactions, how do you, and again, this is back to what we're talking about, how do you think about scaling all the parts of the service? So it's great, you've scaled the read, you scaled the write, you can create the transactions and everything else, but then you've got these asynchronous tasks that might be taking place to process the webhooks that are coming in, to send out the confirmation emails and things like that. It's about thinking about every step of the journey, because if you have a really large on sale and you sell lots and lots of tickets, but then no one gets a confirmation email for 2 hours because the task queues or the services that are sending out emails or generating the PDFs didn't scale alongside the rest of the system, so then they get backed up. That's then a separate problem. So again, thinking about all the parts of the system that need to scale, and a big part of that for us is monitoring and making sure we've got sufficient tooling in place to make sure we can monitor when something might become a problem. Because if an API is not scaling, it becomes evident pretty quickly. You get delays on response times, you get timeout errors, etc., etc. People tend to notice that pretty quickly. If an email is taking 2 hours to go out when it should go out instantly, that's a more subtle thing that you don't really want to wait until the customer's complaining about that. So it's thinking about monitoring lengths of asynchronous queues and other things that you might need to do.
And talking about external dependencies, right? Email is also a tricky one, even beyond the scope that you were just sharing, right? That are your services scaled up for it? But then even if it's peak traffic and you're sending a lot of emails to a specific kind of email provider in a specific country, then there's also that whole system that can get can become the bottleneck as well, right? So
yeah, and I think that's why it's crucial when you're looking at what partners and what third-party systems you want to work with. And I think more and more now SaaS systems are calling out to other services and other systems, so making sure that those systems are capable of scaling and have the things in place. And I think one of the things for us that's quite interesting is when we think about how you test these things, because you can load test your own system, but then if you're depending on a third-party system as part of the flow, how do you build that into the load testing, or how do you build that into your scenario planning to make sure that that's not going to become an unexpected bottleneck in a real life scenario? Yeah.
And what has been your kind of what have you found to be more effective when approaching that? Right? Have you been working together with some of the third parties to kind of coordinate some load testing? You did mention that the payments that you never had any issues, so maybe it's in that case it hasn't been needed. But
so some third party services are good, and we'll document how you can load test with them, or give you recommendations on how to simulate that. And others you have to kind of make certain assumptions and effectively mock them. So you have to create realistic mock experiences of what that might be, whether that's building in delays or other things. But yeah, I think that tends to be a part of sort of a service by service, but some of them are good and give you kind of guidance on what to expect. And again, this comes down to, we're kind of getting really into the weeds now, but if you've got production and development environments, if those third parties have also got production and development environments, and if your development environment is linked to their development environment, you can fall into the trap of doing a lot of testing in the development environment to then discover that the production environment is quite different.
That's I think a widely known, or at least felt ish, right, that things are working well in dev and staging, and then once you get into production, then there's certainly a percentage of issues there that you only have in production. So
exactly, and some things it's virtually impossible to test. I mean, you can't obviously test what an end-to-end payment flow would look like with production cards unless you're willing to go and spend a lot of money. So I think some things you have to mock and you have to make, but then it's kind of working out what the risk is and how you can mitigate it.
And on that point, on the mitigation part, is there, because I think that's big, and I understand some of your focus has been in that area as well. It's like, okay, but one thing is having the scalability as quick as possible, as efficient as possible, being able to predict, but then also preparing for any issues, edge cases, anything unexpected. Is there something that you've been, do I get that right, that you've been focusing on that as well?
Yes, absolutely. And I think I don't want to pretend that we've got all the answers here or that we've solved all the problems. I think it's something we continue to work on. And I think that's a key thing, is to be kind of continually evolving on it. But again, I think for us, the key things are running, looking at disaster recovery scenarios, looking at what happens when things go down, what happens when parts of the infrastructure break. I mean, I think most people are dependent on to some extent third-party systems, whether that's hosting providers or DNS services or reverse proxies and things like that. So I think thinking about how you can mitigate risks there, but then also within our own application, thinking about what happens if the worst case scenario to me is you get an influx of traffic and then everything stops working and the recovery is really slow because you've overwhelmed a bunch of pods, or you've overwhelmed the core application, or the database has gone into a restart or something like that. So I think a lot of the focus we've had has been on things like adaptive rate limiting to make sure that we're stopping traffic before it gets to that point, thinking about rate limiting at different parts of the service. So we rate limit both at the database side, but we also rate limit at the edge, and then we rate limit at the application. So thinking about those protections in terms of, and then the next point for us to think about is kind of traffic shedding. So thinking about what's the core priority traffic that we should be handling versus what's maybe lower priority traffic in those kind of extreme examples. So for me, this is why I say I don't see scaling as a binary thing. It's kind of, how do you protect a system as much as possible when it is under load and stress, so that even if things aren't going 100% according to plan, you're not kind of either available or not available. So, and I think that's a really important part here is how do you think about each part of the application and how you can keep as much of it running as possible, even in the most extreme situations where things aren't going as you expect.
Fully agree, and I think it gets pretty interesting when you then get to kind of the more the chaos engineering side of things. And we did have Colton Andrews, the CEO of Gremlin, the other day in the podcast as well, so talking about chaos engineering and kind of knowingly starting to test the system by kind of making some of the parts of it fail on purpose to see how it reacts as a whole, right? And this kind of the goal, and I think it's probably very hard to achieve the kind of 100%, but I think it's a very interesting goal to start small, but start kind of doing those and seeing how the system reacts, and then trying to improve it.
100%, exactly that. And I think it's that continuous kind of, I think chaos engineering is a great thing, that kind of continuously trying to think about what might happen, and then and then actually running those scenarios and seeing how the system can adapt and you can work on it. Yeah.
Very, very good. I think it's a super kind of 2 or 3 very interesting kind of topics and different perspectives on the work that you do at Lineup. I appreciate you sharing it. One thing, and I think no discussion on scaling and the work that you're doing at Lineup, that we do in ticketing, would be complete without talking about bots, right? So is there kind of any perspective, anything that you want to share on how are you fighting them? What are the things that you're looking at in that area?
Yeah, I mean, I think we're seeing a lot more of them. That's not that surprising. I think there's been a big increase in things like residential properties, and they're a lot more available. So I think ticketing again is slightly stands out there as an industry that suffers from this more than maybe some other industries, and part of that is a lot of the time we're dealing with inventory that may not be priced at the market value. So what I mean by that is often you'll have very high profile bands and things like that who are or artists who are selling tickets to events at a price that is not the highest price they could achieve on the open market. So there is an incentive there then for people to pick up those tickets and resell them at higher prices. And then there's lots of different discussions going on around that, and I don't want to get too much into that now, but the reality is that there is an incentive for people to find ways to buy those tickets and resell them. So we're seeing that the bots are quite sophisticated to the extent that there's bots that will buy tickets and list them for resale in sort of simultaneous, so they can be in the basket and then they can appear on a resale site before they even reach the transaction. And then just the volume that we see, and I would say it's becoming increasingly hard to filter out that traffic and detect it. So it's a big challenge. I think there's a lot of stuff that can be done, and there's things that we can do. I mean, it's a little bit of an arms race. So I think you can introduce things like captures and other things to make the barrier a little bit higher, to make the process a little bit more expensive. I mean, people can obviously, there are capture forms and things where people can fill these out, but it does at least sort of reduce the economic incentive slightly. I think that there's models that can be put in place in terms of how tickets are sold, whether that's through ballots and things like that again can reduce the risk. I think, again, waiting rooms and queues can do an awful lot here in terms of restricting people's access into the flow, and then also shuffling up people who are in the queues and so making it again harder for people to get into the booking place. So again, it's there's no one solution. I think it's looking at each part of the journey, and again, it's very show customer specific, because some customers won't have a problem with it, and some customers will have a really big problem with it. So it's finding a solution that works in each scenario, and then also looking at each part of that booking journey and thinking about how you can mitigate the risk high.
Yeah, and I'm actually also very curious to see kind of the evolution in the next years, because now with more of an agentic web and all that we're moving towards, right? Then now we've been trying to separate between bots and people. I think maybe soon is kind of between bots and other bots that people sent to the queue to get the tickets for, right? So then I think exactly it's not getting any easier, right?
100%. And this is kind of what I mean. I mean, the difference between genuine and not genuine traffic is, and I saw someone the other day said it's not just like the notion of identity is becoming a really hard thing to define, both in terms of online presence and whether that's in videos or images and things like that. This notion of like identity is becoming blurred. So yes, I think you're completely right. As we see more and more agents doing purchases for people and things like that, then that question of how do you filter out legitimate and not legitimate is going to become harder. So yeah, I think it's not going anywhere, and will be a challenge as we go forwards. But it's also an opportunity, I think, to do some interesting things and to stand out and to think about how we can solve these in different ways.
All right, and we're close to wrapping up. I would like to kind of finish it off with a few rapid fire questions. So short questions that ideally it's a short answer as well. You don't have to think too much about it, but we'd love to get your input or your answer. First one, to you, scalability is
challenging.
Yeah. Second question, is there a book, podcast, thought leader, anything that you would recommend to anyone? Could be in this area, could be anything else.
I think lots of books. I find that the engineering blogs of some of the Stripe's engineering blog, I think is always very interesting. Shopify's engineering blog, I think they've done some great stuff. I'm also a big fan of Hacker News, which I think has some great articles in there about these things, so some more technical deep dives. So yeah, those things I think in this sector.
Just two more. Is there a technology that you're excited about right now? And bonus points if you don't say AI, but it's also accepted. I'm excited. It's not particularly new, but I'm continue to be excited about how two things. One, how kind of the SaaS offering is being broken up into different functional pieces that are then being offered as really good kind of optimized versions of what they do. So what I mean by that is, authentication, you've got the likes of people like WorkOS who are doing a really good authentication product. Billing, you've got companies like Lego doing really good billing products of how do you bill for SaaS. So there's this continued kind of trend of thinking about sort of focused parts of an application and how you can build a really good solution for that and then build that out in a way that people can use it. I think there's going to be more of that. And why I think that's interesting is I think these focused products, embedded analytics is another area where I think there's really interesting things happening where we've gone from, these kind of big analytics products to stuff that you can embed into applications, because I think that's an interesting trend. And I think part of that trend is as well the increased commercialization of open source technology, where you have these really great open source projects that seem to have found a good way of commercializing, so that you have some now really big established open source companies that are very profitable and have a commercial offering, because I think that's an interesting way to build software. And I think we're going to see that across other sectors. Sorry, this was a quick fire answer. So yeah, if I'm excluding AI, and I think there's a lot of exciting things in AI and in AI around this as well, in terms of anomaly detection and those kind of things. If I'm excluding that, I would say those things I think are quite interesting. Thank you for sharing. Last question. I hope there. What advice would you give your younger self or someone starting right now a career in this area?
I think specifically in terms of starting companies and being an entrepreneur, my advice would be that it takes practice to do it as many times as you can. I mean, we've been around for a while, but we've been through a few iterations, and I think I think that yes, it does take practice, and if you can do it a few times early on and get started early on, then that helps.
That's it's a good piece of wisdom to wrap this up with. Thank you so much, Barnaby, for your time and for joining us. We went through quite a bit in a topic that I'm very passionate about. So thank you for that.
Absolute pleasure, and really nice to speak to you.
And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@qit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Qit, your virtual waiting room partner. I'm your host, José Quaresma. Until next time, keep it smooth, keep it scalable.